Hello, viewers. I have a question for you. Ask yourself, what is the important lesson that you have learned from your failures? Based on your past experience on failures, if you want to suggest a message to your future generation, then what it could be? These two questions are here. These questions encourages you in self-reflection, introspection, and consideration of your personal growth and values. Hi everyone, especially IIT aspirants. Welcome back to my channel RK Study Circle IIT, where your concepts get cleared concisely. I'm Raj Kumar Nenavath, an alumnus of IIT Guwahati. I'm here to boost up your IIT JEE Maths preparation. Please like, share, and subscribe to my channel RK Study Circle IIT and hit the bell icon to enable the notifications so that you never miss an update and you'll get access to exclusive math content, regular updates, and personal guidance. So, without wasting further time, let's dive into this today's session. Last time I have gone through the chapter number one, that is function and relations. That's lecture number one, in which I have gone through the introduction to the functions, and then the type of functions, range and codomain. And in this session, we'll solve few questions based on the types of functions, like whether the function is one function or onto function. And I'll go through the concepts of onto and into functions. At the same time, we'll have a concept of domain and range as well, and some parts of bijection functions. At the same time, the introduction to the inverse functions. We'll go through inverse functions as well. So if you remember the concept for the last day, let's say f is a function mapping from a to b. Let's say if there is only one mapping is happening from pre-image to the image. Every pre-image is having single image and every image is having single pre-image. Then in those cases, the function is said to be one function. One function. And let's say f is any function which is mapping from a to b, where let's say the function f is mapping more number of pre-images in set A with respect to the set B. Means for the two different values in set A, there is the same output is obtaining in set B, right? Such functions are said to be the many one functions. Such functions are said to be the many one functions. Many one functions or many to one functions, right? And I have discussed some of the methods whether how to define a function is either one or many one. The first one is the analytical method, in which we are writing f of x1 is equal to f of x2 if and only if the input values are equal. Output values are equal if and only if the input values are equal. Then f is said to be one function. One function. Otherwise otherwise f is many one function. If the outputs are equal but the input values are not equal, then such function is said to be the many one function. We will discuss the respective examples in here. And let's say the method number two is the graphical method, in which we are drawing a horizontal line, which was said to be the horizontal line test. Yesterday we have discussed some points about horizontal line test, right? Let's say any curve, if the curve is here which is touching more than one point, then the function is said to be the f of x function is said to be the many one function. And any function which is touching only once the horizontal line, cutting only once to the given function, then such functions are said to be the one functions. Here this straight line is a one function, and all kind of parabolas are many one functions, right? The third method is the method of differentiation, in which we are defining whether the function is strictly increasing or monotonically increasing, strictly decreasing or monotonically decreasing. In any of these cases, the function is said to be the one function. If the function, once it is maintaining the slope is greater than 0, after some point the function f of x is maintaining slope is less than 0 or equal to 0. In such cases we do say the function f of x is the many one function. So if I want to say the function is to be a 1 1, if and only if it must be strictly increasing or monotonically increasing, or strictly decreasing or monotonically decreasing, whatever it is, then the function f is said to be the 1 1 function. Most importantly, one more method is there, that is when representation, when diagram representation. That's what we directly doing. So that is the function mapping from a to b. That's a representation, pictorial representation of Venn diagrams. And here are the four methods what we have discussed. The fourth method is uh, the function mapping from a to b, representation in the form of Venn diagrams. So in order to understand whether the function is 1 1 or many one, let's solve these three questions, where the first question comes out to be the define the type of function whether it is 1 1 or many one, where f of x is given as x cube minus 6x square plus 11x minus 6. And question number 2 is if any function f is mapping from R to R, which is defined as f of x equal to x plus cos x, then define the type of function. The question number 3 is define whether the function f of x equal to 1 divided by 1 plus x square is 1 1 function or many one functions. The solution for question number 3, let's say f of x is given x cube minus 6x square plus 11x minus 6. Right, this is a cubic equation in the sense I can even write f of x equal to y, that is equal to x minus 1 into x minus 2 into x minus 3. Sir, what are 1 comma 2 comma 3? These are the roots of this cubic equation. So roots of cubic equation in the sense it is forming a graph. Let's say here is x equal to 1 is mentioned, here is x equal to 2, and x equal to 3 is mentioned. 1 comma 0, 2 comma 0, and here it is 3 comma 0. Let's see at x equal to 0, in the sense completely y-axis. On y-axis, what about the value of f of x or the value of y? That is negative, right? When I keep this value equal to 0 means I am left with minus 1 into minus 2 into minus 3. In the sense this value comes out to be the negative, and it is minus 6. The value comes out to be the minus 6. So for the rest of all negative values, the entire f of x or y is always negative value. Means I am writing here it is 6 comma 0. This is the point which is representing 6 comma 0, and the f of x goes like this, right? And I have established the graph, means I can go through the horizontal line test. If I establishing a horizontal line test, I can see the horizontal line is cutting f of x more than 1 point. Then f of x is said to be the f of x, that is cubic equation, is said to be the many one function. Right? Let's look on to the question number 2. In question number 2, it is mentioned that the function is defined on real numbers, that is f is a function mapping from R to R, and it is defined as f of x is equal to x plus cos x. Basically what can we do here is we can solve this question in two ways. Like, let's see f dash of x. In the sense it is 1 minus sine x. See, sine x value is always lying between minus 1 to 1, and minus sine x value is also always lying between minus 1 to 1. Let me add 1 on all sides. Then I can write this 1 minus sine x value is greater than or equal to 0 and is less than or equal to 2 on right hand side. 1 minus sine x is nothing but my f dash of x value. In the sense f dash of x, it is either equal to 0 or greater than 0. Means I can write d by dx of f of x, it is greater than or equal to 0. Means the function f of x is monotonically increasing. Then f is said to be the 1 1 function. Right? Let's do it in other way, like the graphical representation. When I drop a graph, and I drop a graph, let's say this one is x-axis and here it is the y-axis. Here it was mentioned, it is the first function, it is equal to x, y equal to x, and the second function it is mentioned, that is cos x. Cos x is moving along with this y equal to x line, like this. So I can write down overall the function in overall I can write down the function, the graph of the function, x-axis, and here is the y-axis. So I'm taking like this. So what could be the value on y-axis? I can write the value of y-axis comes out to be the x value equal to 0. X value 0 in the sense, what is the point over here? 0 comma 1, right? 0 comma 1 means even though if you drop a horizontal line test here, if you draw a horizontal line test, this line cuts only once. I have drawn this one little differently, but if I drop a line, horizontal line test like this, definitely the function, this function f of x is cutting only once to the horizontal line test. So still I can say the function f of x is 1 function. The function f of x is 1 function. Let's look on to the question number 3. It was mentioned that f of x equal to 1 divided by 1 plus x square. So in order to get the graph of this function, you must know the graphical transformations. So the graphical transformation, if you basically write y equal to 1 plus x square, what it could be? 1 plus x square in the sense you're writing the graph like this, where the minimum value is coming out to be the y equal to 1 and the maximum value is infinite. So this is the function y equal to 1 plus x square. And if I want to draw for the same like at x equal to minus infinite, the value of f of x is also minus infinite. When it keep on getting increase, and it will rise to the value 1, and then it keep on getting decreases. So this is the function which is given f of x equal to 1 divided by 1 plus x square. Sir, how you got this expression? So when the value of x is infinite, the value of y comes out to be the 0. It is reaching like this, and then it is again moving in this way. So the function is the function f of x. When you drop a horizontal line test, this horizontal line test is cutting the f of x at more than 1 point. Means the function f of x is following, f of x is said to be the many one function. Right? So this is the function which is many one in nature. So I hope you understand what are the functions, how they are defined as one function or many one function. I hope you have learned that one. And let's go for the next one, that is domain, codomain, and range. In the first class itself, I have explained you what is domain, what is codomain, and range, these three important points. And I want to write once more. It is the domain in the sense the possible values of x. The possible values of x, or x in the sense we call it as inputs, right? The possible values of inputs also, the possible values of inputs, and we write x also as variable, whatever it is, the possible values of variables, where the function function f of x is defined, the function f of x is defined. So firstly we'll talk about the range. Range is nothing but the possible values of y, the possible values of y, values of y, where f of x is defined. Means y, I can write it as the set of output values, and I can write it as dependent variable, where y is dependent on x and x is a independent variable, right? And codomain in the sense, codomain is the entire value of the set b, and range is just a small part of set codomain, or it sometimes it might be equal. The set of range could be equal to codomain, or in all other cases the range is always lesser set than that of the given codomain. Means the length of codomain is much more larger than the length of range. One more thing, if I want to write a range is nothing but I can mention it as minimum value comma maximum value. The number of values which are ranging from minimum value to the maximum value of what? Of given function f of x. Minimum value of f of x and maximum value of f of x. So that is known to be the range. And this range is always within codomain values, or sometimes the range is entirely equal to the set of codomain. So we'll learn about it in future. Firstly, we'll solve 2 to 3 questions based on domain and range. Let's look into the few questions here to understand the domain and range of any functions. Like I have taken particularly the function f of x equal to x plus 1. I have taken simple expressions so that I can conveniently explain you what the domain and codomain is. Sorry, what the domain and range is. So for the first question, f of x equal to x plus 1. The first question, f of x equal to x plus 1. So at whatever be the values of x is, x value, let's say it is defined for all the real numbers. So y value, that's nothing but f of x is also defined everywhere. That's why the function, the set of values of x is said to be what? Uh, the set of values of x are said to be the domain values, and the set of values of y are said to be the codomain, sorry, range values. So the when it comes to the graphical representation, let me say I am representing the graph y equal to mx plus c in that format, so that I am writing this is the expression x plus 1, where I am getting the value at x equal to 0, it is equal to 1, and here it is minus 1 comma 0. This is the graphical representation of that expression. If I'm saying what kind of function it is, it's a linear equation, right? So the horizontal line test is cutting only once to this expression, hence I can say the equation is 1 1 in nature, 1 1 function in nature. The next one, let's look on to the question number 2. Let's look on to the question number 2, where f of x is mentioned 1 divided by 1 plus x. So here we need to note down that the function is not defined when denominator equal to 0. If this denominator is becoming 0, then the function is not defined. That's why I'm just writing x plus 1 should not be equal to 0, means x should not be equal to minus 1, means x value is valid for all the real numbers except minus 1, x equal to minus 1. And I am writing all the possible values of y. The y values are ranging from minus infinite to plus infinite. It is in overall real numbers. Let's look into the graph of 1 divided by 1 plus x. Let's see what I have written. At x equal to minus 1, the function is not defined, right? At x equal to minus 1, the function is not defined. Means wherever the function is not defined, I am just writing that expression comes out to be like this, and the equation is going like this. This is the functional equation f of x equal to 1 divided by 1 plus x is 1 plus x. That's it. So when you drop a horizontal line test, even the horizontal line test drawn anywhere, it is cutting only at one point to the f of x, means the function f of x is said to be the 1 1 function. Let's look into the third. In the third question, it is mentioned that f of x equal to under root 1 plus x. This under root values are not defined for negative values. Under root values are not defined for negative values. It is only defined whether the function f of x is either greater than 0 or equal to 0. It is defined only for those things. Means I can write x plus 1 must be greater than or equal to 0, in the sense x is greater than minus 1, greater than or equal to minus 1. So then I am writing x value is minimum value minus 1 and the maximum value up to open bracket infinite. So for this expression, the value of y, sir, what about the value of y? So it is little difficult, not even difficult. You can even solve through analytical method. Y values are ranging from 0 to plus infinite. Y values are ranging from 0 to plus infinite. If you look onto the graph of f of x equal to under root under root x plus 1. Let's say it is not defined at x equal to minus 1, right? It is not defined at x equal to, sorry, x equal to minus 1. It is defined since at that point it will become 0, right? Even 0 is also the solution of the function, means the function under root x plus 1 is coming like this, so that I can write for any value of x on left hand side x, let's say this value equal to x equal to minus 1, right? The entire perpendicular line for the left handed side, the function is not here, means the function is not defined beyond minus 1 on left hand side. The function is defined only on right to the x equal to minus 1 line, means I can write the values are ranging from minus 1 to infinite for x values. And what about the y values? Y values are ranging from minimum value 0 and maximum value it reaches up to the infinite. So 0 to infinite is my range, and minus 1 to infinite is my domain value. Let's have a look on fourth question. It is like this, and the fourth question was given in logarithmic form, that is f of x equal to log of 1 plus x or x plus 1 base e. The logarithm of any value, logarithm of any function, let's say log of f of x is mentioned. This function is defined only for x value strictly greater than 0, and f of x value is not defined when it is equal to 0. Log of 0 is not defined. F of x value less than 0, in the sense the function is negative. For negative values also log function is not defined. So the one and only case the total overall function defined is the internal function must be a positive value, means let me write x plus 1 is must be greater than 0, means x value is greater than minus 1. This is the value I'm saying. X value is ranging from minus 1 to infinite. And if I'm drawing a graph, let's say this one is x-axis and here it is y-axis. So the critical point is x equal to minus 1, right? X equal to minus 1 is the critical point. With respect to this critical point, the graph is getting like this. Where it is passing through origin, and I can write down at origin x value equal to 0, in the sense when I substitute x equal to 0 here in this expression, log of base c 0 plus 1 it is 1, log of 1 is always 0. So hence the value the function f of x passes through origin, and the values are only belong to minus 1 to infinite. It is open bracket, not a closed bracket one. And what about the value of y? The values of y are only belonging from minus infinite to maximum value is 1. The y value belongs to this one, means y equal to minus infinite to 2 is the range of my function f of x equal to log of x plus 1 base c, and x belongs to minus 1 to plus infinite is my domain value. I hope you understand the concept of domain and codomain. From here we'll start the next concept. Let's have a look on to the further concept, that is onto functions or into function. A function is said to be the onto if and only if range is exactly equal to codomain, means the size of range equal to codomain size of codomain. Then we can say the function f is onto function. If it is not possible, means the range is not equal to codomain, in the sense a range could be a subset of codomain, but it is the range set is never be equal to codomain. In such cases may the size of range is not equal to the size of codomain. And the function f is said to be the into function. It all depends on range, whether the function is onto or into function. Let me consider the same examples what we have solved, the question number 1, 2 and question number 3, where I have written the function whether it is 1 or many one function. Let's define the same questions here. Means question number 5 is the define the type of function whether it is onto function or into function. The function is cubic equation. The question number 6 comes out to be the function f is defined on R to R, means f of x equal to x plus cos x. Then define what type of function it is, onto function or into function. Question number 7, define whether the function 1 by 1 plus x square is onto function or into function, right? Sorry, onto function or into function. Then let's start doing these, solving these questions. We can define the range and graph, the range and codomain range from graph, right? So by using graph itself, we can simply say the function is onto or into. So from a graph, you are supposed to define whether the function is given one function or many one function, or and it is onto function or into function. We can predict by simply looking at the graph. So you must be able to draw a graph of any function. First learn the graph of basic functions, like what is the graph of e power x, what is the graph of a power x, what is the graph of quadratic equation, cubic polynomial, cubic equation, and biquadratic equation, what is the graph of reciprocal functions. So those we will discuss everything in while we are talking about the graphical transformations. So let's define these questions right now. When it comes to question number 5, the function f of x is given the cubic equation, that is x cube minus 6x square plus 11x minus x, which is holding x equal to minus 1 and x minus 2 and x minus 3 are roots of this cubic equation. Let's say the function is defined on R to R, real numbers to real numbers. Mean the first R is defining you the domain values, that is the x values are moving from minus infinite to plus infinite. At the same time, the second R representing you the codomain values, where the codomain values are ranging from minus infinite to plus infinite. At the same time, when it comes to the range values, when you put x equal to minus infinite, you will get the y value is also minus infinite. And when you are substituting x equal to plus infinite, you will be getting y equal to plus infinite. The y values are ranging from minus infinite to plus infinite, and codomain values are also ranging from minus infinite to plus infinite. Means the range is equal to codomain. What can you say? The function, if and only if the function is onto function, onto function. All right, let's go with the question number 6. This is the actual graph of the function f of x equal to x plus cos x, where if you're getting a horizontal line test, it is cutting only once. So then we can say the function is one function. At the same time, if you look onto the this sketch, if you look onto this sketch, whatever be the values of x are, the function f of x is defined. So I can take the values from minus infinite to plus infinite, the domain values from minus infinite to plus infinite, and the codomain values are also ranging from minus infinite to plus infinite, minus infinite to plus infinite. Means the function f is defined on R map, f is mapping from R to R. Likewise, wherever you are substituting the value of x equal to minus infinite, you will get y values are also minus infinite based on the first x value. And whatever be the value of x here in cos x, that is always plus or minus 1. So it all purely depends on the outside function x, right? And when you are substituting the value of x equal to plus infinite, you will result in getting y equal to plus infinite. So y values are varying from minus infinite to plus infinite. At the same time, codomain values are also varying from minus infinite to plus infinite. So I can say the size of range is same as size of codomain. So the function f of x equal to x plus cos x, it's a onto function, it's a onto function. Question number 7, it is given as f of x equal to 1 divided by 1 plus x square. The function f is defined on R to R. Means the domain values are all real numbers and codomain values are also all the real numbers. Then domain values are all real numbers. Domain in the sense the x values are belong to all the real numbers. Codomain values means codomain values is also belongs to the real numbers. So let me draw the graph of 1 divided by 1 plus x square. Previously we have defined 1 divided by 1 plus x square, where the maximum value is coming out to be the y equal to 1. Y equal to 1. I am writing this one is 0 comma 1, 0 comma 1, and the possible values of y are mapping from y approximately equal to 0, y value approximately equal to 0 to y value equal to 1. So value of y is open bracket 0 to close bracket 1. This is the range value is this one, or you can even say the length of range. But the length of codomain is much more greater than the length of range, right? length of codomain is much more greater than the length of range. So you can say range is a some part mean subset. Range is the subset of codomain. Range is a subset of codomain. Based on this one, I can say range is not equal to codomain in the sense the given function f of x is said to be the given function f of x that is equal to 1 divided by 1 plus x square is a into function but not onto function. If I want to say the function is said to be the onto, then the range and codomain must be equal. Here the range and codomain are not equal, that's why I'm writing it as into function. So I hope you understand the concept of onto and into function also. Let's talk about bijective functions and the inverse functions. So before going to talk about the bijective functions, I wanted you to remind that I hope you know what are surjective. Surjective function is nothing but it is as same as onto function. Both of them are same. The names are different, but the values are same and their meanings are also same. And let's say I'm writing injective function. Injective function is nothing but a function must be one function. One function. So out of all one function, many one function, onto function and into function, you are supposed to remember the condition for these two, one function and onto function, right? So after all, and let me write down the actual part, that is bijective function. Bijective function or bijection or bijection. The function which follows a function which is both one one and onto or a function which is both surjective and and injective. Such functions are said to be bijective functions. Such functions are said to be bijective functions or bijections. Whatever you want to write, you just write it. Let's have a small talk on inverse of a function too. Let's have a small talk on inverse of a function. Let's say a function is mentioned a to b. A function is mapping from a to b. Function is mapping from a to b. Then inverse of a function must map from b to a. Inverse of a function must map from b to a. Means what I supposed to write? If I'm writing here it is, it must be the a, and here the first function must be the b and the second function is a. So here it is f inverse function. So what I'm writing, a is my domain and b is my codomain set, right? Here b will become domain for f inverse and a will become codomain for f inverse function. And inverse functions are defined only for bijective functions. Inverse functions are defined only for bijective functions. F inverse functions are defined only for bijective function. Bijective functions. Bijective functions in the sense the function must be both onto function and one function. A function must be both one and onto. And that's it for the class today. I'll discuss the rest of the things regarding the inverse of a function in next class. And to summarize for today's session, we have covered the few questions on one and many one concept, the concept of domain and range, and after that we have done through onto and into function and some questions based on onto into functions. Some small concept based on bijection. Means bijection is set, a function is said to be bijection if and only if the function is both surjective and injective. And I hope you know the surjective in the sense the function is said to be the onto function, injective in the sense the function is said to be the one function. And introduction to the inverse function. Inverse functions are defined only for bijective functions. And I hope you understood the concept well for the day. Here is a pro tip for you all. Consistency is the key to success. Consistency is the key to success. And believe in yourself, practice consistently. then only you will be the winner of a race. And thank you for watching my video, and thank you all for your support and likes towards my channel. And this is Raj Kumar Nenavath. Stay tuned for the next upcoming lecture, which is going to be much important for you all. And signing off. Bye.